Okay, so I wanted to do example 7F again, just because I know I got a little muddled in class today because I had some mistakes in my top hat. So the way you would do this problem, you might think, let's undo the log 2. That might be your idea. And so to do that, you would apply 2 to the x to both sides. So take 2 to the power of both sides. And this is allowed because 2 to the x is monotone increasing. So the exponential function 2 to the x looks like this. It's monotone increasing, so you're allowed to apply it to both sides. So if you do that, you get 3 to the x, 3x. So let's do it in 2 steps. 2 to the log 2 of 3x less than or equal to 2 to the minus 3. So that's legit. And 2 to the log 2, these two cancel each other out, so you get 3x is less than or equal to 2 to the minus 3, which is 1 over 8. So x has to be less than or equal to 1 over 8 divided by 3, which is 1 over 24. And all of this is legit. So all of these steps are true, except for we have deleted some of the information. So this is correct. There's no mistake so far, but we have forgotten something. And the thing we have forgotten comes from this original thing, and that is log 2 implicitly, without saying it, so implicitly just means without saying it, 3x must be bigger than 0. And this is hidden inside the log 2 because the log function has a domain of positive numbers. So just by writing log 2 of 3x, automatically 3x has to be bigger than 0. And the problem you can see is that when we start doing these steps, we lose that information. So by the time we get to this step, the information that 3x is bigger than 0, is gone. So by the time we get to here, this information is totally gone. So to fix this problem, what you have to do is you have to keep track of the information a different way. So I think what I would do is to do the problem, let's do it from scratch one more time and fix this mistake. So log base 2 of 3x less than or equal to minus 3. So this is what I would do. I would apply 2 to the x to both sides, and also explicitly write down 3x bigger than 0. So if you do that, you have two things. You have 3x less than or equal to 2 to the minus 3 and 3x bigger than 0. So now it's correct. Now the implicit part has not been lost. So you get x less than or equal to 1 over 8 divided by 3 and x bigger than 0. This is x less than or equal to 1 over 24 and x bigger than 0. You can write this in interval notation. This is x is in 0 to 1 over 24. Let's do it this way. Minus infinity to 1 over 24. And is an intersection 0 to infinity. And this is the same as x is between 0 and 1 over 24. So that's the real final answer. And if you don't remember this part about the 3x being bigger than 0, you're going to get the wrong answer. You're going to have negative numbers, and that's not allowed here. So that is it for example 7F in gory detail.